Article 210.85 of the National Electrical Code defines unfinished basements as portions or areas of the basement not intended as habitable rooms and limited to storage areas, work areas, and the like. A woodshop in a basement, while it may be a finished room, would still be considered an unfinished basement area under Article 210.85 because it is a work area. This is because the definition of unfinished basement focuses on the intended use of the space, not its finished state. According to the 2020 National Electrical Code, all 125-volt, 15 and 20 ampere receptacles installed in unfinished basements, including work areas like wood shops, must be GFCI protected. This requirement is intended to provide additional protection against electrical shock hazards that may be present in these areas, where moisture, dust, and metal shavings can create potential hazards. Based on the NEC requirements, the power tool outlets in the basement wood shop must be GFCI protected. There is no option to opt out of GFCI protection for these outlets. It is important to note that the NEC provides specific exceptions to the GFCI protection requirement for certain types of equipment in unfinished basements. However, these exceptions do not apply to power tool outlets in a wood shop, which are typically used with portable cords and are likely to be used in damp or dusty conditions. Let's delve deeper into the specific requirements and reasoning behind GFCI protection in unfinished basements, particularly focusing on areas like wood shops. Firstly, we need to understand the fundamental purpose of a GFCI, or ground fault circuit interrupter. A GFCI is a safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing into and out of a circuit. Under normal circumstances, these currents should be equal. However, if a ground fault occurs, meaning that current is leaking to ground, a GFCI detects this imbalance and quickly interrupts the circuit, typically within a fraction of a second. This rapid interruption can prevent serious injury or even death. Secondly, the NEC, which is a widely adopted standard for safe electrical installations in the United States, mandates GFCI protection in specific locations where the risk of electrical shock is heightened. Unfinished basements are one such location. The rationale behind this requirement is that basements, particularly unfinished ones, often present conditions that increase the likelihood of electrical shock. These conditions may include moisture, dampness, concrete floors, and the presence of grounded metal objects such as pipes and appliances. In a woodshop environment, these risks are further compounded by the presence of sawdust, metal shavings, and the use of power tools, which can potentially have damaged cords or faulty wiring. Now, let's consider the specific wording of Article 210.85 in the NEC, which addresses GFCI protection for dwelling units. This section states that all 125-volt, 15 and 20 ampere receptacles installed in unfinished basements must be GFCI protected. The key phrase here is unfinished basements. As we discussed earlier, the definition of an unfinished basement according to the NEC is not solely based on whether the space is aesthetically finished with drywall and flooring. Instead, it focuses on the intended use of the space. If a portion of the basement is used for storage, work areas, or similar purposes, it is considered an unfinished basement area, regardless of its cosmetic appearance. Therefore, even if a basement wood shop has finished walls and flooring, it still falls under the definition of an unfinished basement area because it is a work area. This means that all 125-volt, 15 and 20 ampere receptacles in the wood shop must be GFCI protected. It's important to note that the NEC makes no distinction between receptacles used for general lighting or appliances and those used for power tools. All receptacles meeting the voltage and amperage requirements must be GFCI protected. Now, let's address some common misconceptions or objections that individuals may have regarding GFCI protection in wood shops. One common concern is that GFCI protection can cause nuisance tripping, especially when using older power tools or tools with universal motors. Universal motors, which are commonly found in many power tools, can sometimes generate electrical noise that can trigger a GFCI. While nuisance tripping can be frustrating, it's important to remember that the primary purpose of a GFCI is to protect against electrical shock. If a GFCI is tripping frequently, it's a sign that there may be an underlying electrical problem that needs to be addressed. This could be a faulty tool, damaged wiring, or a problem with the GFCI itself. Another misconception is that GFCI protection is not necessary if the electrical system is properly grounded. While grounding is an important safety measure, it does not provide the same level of protection as a GFCI. Grounding helps to ensure that if a fault occurs, the circuit breaker will trip and energize the circuit. However, it may not prevent a person from receiving a shock if they come into contact with a live wire before the breaker trips. A GFCI, on the other hand, detects even small amounts of current leakage and interrupts the circuit much faster than a breaker, providing a higher level of protection. Now, let's discuss the specific exceptions to the GFCI protection requirement that are mentioned in the NEC. As he noted, the NEC provides exceptions for permanently installed appliances, equipment not subject to being wet or damp, and equipment located more than 6 feet above the floor. However, these exceptions are generally not applicable to power tool outlets in a woodshop. Power tools are typically used with portable cords, and they are often used in damp or dusty conditions. Additionally, they are typically located within easy reach of the user, not more than 6 feet above the floor. Therefore, the GFCI protection requirement applies to these outlets. It's important to understand that the NEC is a minimum safety standard. Local jurisdictions may have additional requirements or more stringent interpretations of the code. It's always a good idea to consult with a qualified electrician or local building inspector to ensure that your electrical installation meets all applicable requirements. In summary, the power tool outlets in a basement woodshop must be GFCI protected in accordance with the NEC. The customer cannot opt out of GFCI protection for these outlets. While nuisance stripping may be a concern, it's important to prioritize electrical safety. If you have any concerns about GFCI protection or electrical safety in your woodshop, consult with a qualified electrician. They can help you identify and address any potential hazards and ensure that your electrical system is safe and code compliant. To further elaborate on the practical implications and best practices for GFCI protection in a basement woodshop, let's consider several additional aspects. Firstly, the selection of appropriate GFCI receptacles or circuit breakers is crucial. There are two primary types of GFCIs available: GFCI receptacles, which are installed at the point of use, and GFCI circuit breakers, which protect an entire circuit. For a basement woodshop, either option can be used, but there are some factors to consider. GFCI receptacles are generally less expensive and easier to install than GFCI circuit breakers. They also provide localized protection, meaning that if one GFCI trips, it does not affect other circuits in the house. However, they require more wiring and can be more difficult to troubleshoot if there are multiple GFCIs in the same circuit. GFCI circuit breakers, on the other hand, protect the entire circuit, making them easier to troubleshoot. However, they are more expensive and can cause nuisance tripping if there are multiple devices on the circuit that generate electrical noise. When selecting GFCI receptacles or circuit breakers, it's important to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories or ETL. This ensures that the products have been tested and certified to meet safety standards. Secondly, proper installation of GFCI receptacles or circuit breakers is essential for their effective operation. GFCIs must be wired correctly to function properly. It's important to follow the manufacturer's instructions carefully when installing GFCIs. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the installation. Thirdly, regular testing of GFCIs is necessary to ensure that they are working properly. GFCIs should be tested at least once a month by pressing the test button on the receptacle or circuit breaker. If the GFCI trips when the test button is pressed, it is working correctly. If it does not trip, it may be faulty and should be replaced. Fourthly, addressing the issue of nuisance tripping is important for ensuring that the GFCI protection is not bypassed or disabled. As mentioned earlier, nuisance tripping can occur when using older power tools or tools with universal motors. To minimize nuisance tripping, consider the following measures. Firstly, use newer power tools that are designed to be compatible with GFCIs. Secondly, ensure that all power tool cords are in good condition and free from damage. Thirdly, avoid using extension cords, as they can increase the risk of voltage drop and nuisance tripping. Fourthly, if nuisance tripping persists, consider using a GFCI with a higher trip threshold. However, it's important to consult with a qualified electrician before making any changes to the GFCI protection. Fifthly, educating users about the importance of GFCI protection is crucial for promoting electrical safety. Woodshop users should be aware of the hazards of electricity and the importance of using GFCI protected outlets. They should also be trained on how to test GFCIs and what to do if a GFCI trips. Sixthly, maintaining a clean and dry work environment can help to reduce the risk of electrical shock. Sawdust, metal shavings, and moisture can all contribute to electrical hazards. Regularly clean the work area and keep it dry to minimize these risks. Seventhly, using appropriate personal protective equipment can provide an additional layer of protection against electrical shock. Wear safety glasses, gloves, and appropriate footwear when working with power tools. Eighthly, having a readily accessible first aid kit and knowledge of basic first aid procedures can be invaluable in the event of an electrical accident. Be prepared to provide immediate assistance to anyone who may be injured by electricity. Ninthly, conducting regular electrical safety inspections of the woodshop can help to identify and address potential hazards before they cause an accident. Inspect electrical cords, outlets, and equipment for damage or wear. Ensure that all electrical connections are tight and secure. Tenthly, staying informed about changes to the NEC and other electrical safety standards is essential for maintaining a safe work environment. The NEC is updated every 3 years, so it's important to stay abreast of the latest changes. In addition to the above considerations, it's also important to be aware of the specific requirements for wiring and grounding in a woodshop. The NEC provides detailed requirements for the size and type of wiring that must be used in different types of occupancies. It also specifies the requirements for grounding electrical equipment. Proper wiring and grounding are essential for ensuring that the electrical system is safe and reliable. In conclusion, GFCI protection is a critical safety measure in a basement woodshop. By understanding the requirements of the NEC, implementing best practices, and educating users about electrical safety, you can create a safer work environment for everyone. Remember, electrical safety is everyone's responsibility.